This is an experiment sending two identical square waves using a software program running on the Macintosh computer. We are sending two identical square waves into a Phanotron bulb. Here perhaps you can see a better view of the two square waves which are running simultaneously. Actually, these are two programs running simultaneously going to the audio output of the computer. That output is then fed into the OM1 transmitter, antenna tuner, amplifier, and to the Phanotron. There is a control on this program for the duty cycle of the square wave right here. And of course, on the parallel program running, we can also do it. So right now, both square waves are running with a duty cycle of 50%, a true square wave. Let's now begin to alter the duty cycles and see what happens to the Phanotron. I've dropped the Phanotron tube down using the antenna tuner to just over 60 watts, about 62 watts. The SWR about 1.2. I wanted to drop the power down a little bit because I think they're going to see a power increase as I change one of the square waves. Now we'll slowly change the duty cycle of just one square wave. So one square wave will remain at 50% duty cycle, and the other will gradually drop, and we'll see what the result will be on the Phanotron. I've dimmed the lights in the laboratory, and here we go. So we have two square waves, 50% duty cycle. I'll call out the second square wave input as I change the duty cycle. 47%. 45%, 43%, 41%, 40%, 39%, 38%, 37%. My eyes see a general brightening of what looks to be a portion of the plasma. 36%, 35%, 33%. Just by changing the duty cycle, the power's gone up to over 100 watts. Where are we? 125 watts, which exceeds my rating on my Phanotron by 25 something watts. And you can see the reflected power, SWR, has climbed. I'm going to have to reduce that to protect the Phanotron and the amp. Here you can see the two square waves, the one on the left, 50%, the one on the right, 33% duty cycle. Net result was more power into the Phanotron tube, but also an increased SWR. We will lower the tuning of the MFJ a little bit so we don't blow out our amplifier and get electrodes in the Phanotron, and we'll continue the experiment. I've adjusted the amplifier output and the MFJ tuner. You can see we've got the power back down to 60 watts or so, 70. Actually, it's climbed in the last 30 seconds. I see the power rating and the SWR climbing, but still we seem to be in safe limits, so we'll continue the experiment and see what happens. Actually, I'm going to watch the power meter because without making any adjustments, having left the square waves at 50% and 33% duty cycles, the amount of watts has slowly climbed by itself since I readjusted everything, and the SWR has slowly climbed. I've turned the amplifier down so I get 60 watts now, and an SWR of just over 1.1. Let's continue the experiment from this point now. Here's a steady shot of the MFJ meter now. Notice the very slight vibration in the SWR needle. Very subtle back and forth vibration, also in the power level. Okay, the last reading was about 50 watts, SWR 1.1. Now let's start changing the second duty cycle again. We're at 50% for one square wave and 33% for the other. 30%, 28%, 23%, 20%, 17%. Power meter now reads 70 watts, SWR 1.2. We have 50% duty cycle on wave 1 and 17% duty cycle on wave 2. 2 square waves. 15% duty cycle on wave 2. 13%. 11%, 10%, 8%. Power level seems steady at 70 watts, SWR 1.2. I do hear some more upper harmonics coming off the glass bulb though in the laboratory here. Let's decrease the second square wave duty cycle some more. 6%, 5%, 4%, 3%, 2%, 2 square waves, one with a 50% duty cycle, the other with a 2% duty cycle. %. The meter now reads 65 watts, SWR 1.2. Now, one square wave has a 0% duty cycle, the other a 50% duty cycle, and power reads about the same, 65 watts, SWR 1.2. Let's slowly bring that up. So we have 50% of wave A and moving from 0% duty cycle upwards in wave B. Both are square waves. 2%, 5%, 7%, 11%. I can hear pitches changing coming from the bulb. 14%, 16%, 22%, 25%, 30%, 34%. The meter now reads 60 watts, SWR very close to 1.1. So we've had a reduction of SWR and a little power reduction. We have 50% duty and 34%. Let's continue to increase that. 36%. 41%. The luminosity of the plasma is visibly reducing. 44%. Power level now reads 30 watts and SWR below 1.1. But you can see we still have a plasma in the bulb. Let's continue increasing the duty cycle. 45%, 47%, 49%, 50%. Both square waves at 50%. Power level reads 30 watts, SWR just below 1.1, but we do have a plasma. Let's increase the duty cycle of the second waveform. See if we get any effect. 55%, 58%, 62%, 69%. We got a sudden power increase somewhere around here. Let's see where it happened, right here. Starting around 68%. 50% one square wave and 68% duty cycle in the other. The plasma light got brighter. The wattage came up to 40 watts. SWR right on 1.1. Let's continue to increase the second duty cycle. 72% increase in plasma brightness. Continue to increase, 75%. 81% plasma increases in brightness. 90%. 50% duty cycle, one wave, 90% the other. Power rating is now just about a little over 60 watts. SWR 1.2. There's been a general power increase here. Let's increase the second duty cycle. It's at 90%, 94%, 96%, 97%. Duty cycle, the other is 50%. Power readout, 60 watts, SWR 1.2. %, duty cycle, 100% duty cycle. Now decreasing the duty cycle, you see a visible decrease in the brightness of the plasma. Here you can see I'm increasing the duty cycle and decreasing the duty cycle. 27%, and it's very bright here. It covers more of the electrode and is brighter as you get up to the higher percentages. 67%, 84%, 100%, 66%. Notice the plasma came down the stem of one of the electrodes at 39%. Now it starts increasing again, 27%. And that's 0%. 8%. It's a kind of a tuning going on. Now we're at the maximum we seem to get is around 2%. And then it begins to reduce as I increase it. 9, 10%. It's reducing. Now I'm at 36%, very weak. And almost fades out completely at 42%. starts to, there it shifts again. The plasma comes off the stem and moves just towards the leaves of the electrodes. Here I see plasma on the stem of the electrode on my side, and here the plasma, now it jumps to between the electrodes, and that happens at 66%. The plasma jumps from the stem of the electrode to the space between the electrodes. Now we increase it to 72%, 95%, and that's about as bright as it gets. Decreasing, 88, 73, 67, 63, around 45. Let's see where that happens. At a certain point, the plasma jumps down the stem around 46%, and now it starts to increase again. Now we have the stem has a plasma on it, the electrode stem, and between the electrodes. That's fascinating. Here's a 1%. I see a plasma around the base of the electrode or the stem of the electrode and between the electrodes. The plasma on the stem extinguishes when you hit this point, which is around 40, when you climb up above 46% or so, there's a triggering point, 64%. There's the stem at 49, stem goes off at 66, plasma increases between at 77, and continues to brighten all the way up to 100. Here we have 97% on one frequency and 50% on the other. Power readout is 60 watts, 1.2 SWR. Now we'll do a quick experiment where we send the same frequency, which is 1034 Hertz has been this frequency as I vary the duty cycles. Now we're sending in 3 square waves. One of them I will leave at 50%, and then I'll call out the other 2 as I alter them. One is on 18% right now, and the other is on 32. So I'll call out the middle frequency. We'll say frequency 1 is at 50% always. Frequency 2 will be the next thing I'll call out. It's duty cycle frequency 3. So the 2 numbers you'll hear will be duty cycle of frequency 2 followed by the duty cycle of frequency 3. Let's go up to 50% on number 2. And let's go to 50% on number 3. 3 square waves going into the Phanotron. 3 square waves at 50% on the same frequency. The power jumps to 90 watts, 1.2½ SWR. Try not to burn out the bulb here. Okay, now changing the second and third duty cycles. 36% and 50%. 36 and 29. 21 and 29. 21 and 10. 11 and 10. 11 and 3. 11 and 24. 11 and 48. 11 and 56. 11 and 70. 11 and 89. The sounds gets louder from the tube. 11 and 89. 34 and 89. 60 and 89. 87 and 89, and the stem lights up. Plasma goes out at 100%, completely out when I hit 100% on the middle one. I back it down to the 90s, 94, 100, plasma goes out. So 189, no plasma. Drop it to 98 and 89, I get some plasma. Let's leave it at 98 and alter the third slider. 98 and 100. $98 and 85, 98 and 79. My 98 looks funny. Hold on, let me see. There we go. I think it wasn't really 98. Okay, this is 95 and 79. Let's back this up here. 95 and 95. 95 and 76. 95 and 50. 95 and 42. 95 and 30. So we have 3 square waves, one at 50% duty, one at 95% duty, and one at 30% duty. I'm just calling out the second and third wave duty cycles. 95 and 13. 95 and 0. 95 and 12. Change the middle one. 82 and 12. 64 and 12. Stem goes off. 56 and 12. 41 and 12. Stem goes on. 34 and 12. 23 and 12. 5 and 12. Now let's try one experiment where we put them all very small, like 5%, and see what happens. We have 5 and 12, and I'm going to change the first duty cycle to make it smaller. Let's see what happens. So we have something 5 and 12. 29, 5 and 12. 25, 5 and 12. Plasma goes completely out and I hit 0 on the first frequency. 10, 5 and 12. 30, 5 and 12. 50, 5 and 12. 67, 5 and 12. 96, 5 and 12. 100, 5 and 12, no plasma. Fascinating experiments with duty cycles and multiple square waves into a phanotron bulb.